Alright, so this is I'm going to record the solution video for this last problem. The problem is based on the previous day's easy version, and the problem was you're given an array, you need to make it into subarrays, where the subarrays are kind of disjoint but contiguous, so they need to be non-overlapping but also combined to the whole original array. So basically you're splitting up the array into some number of subarrays, and you're trying to minimize the cost, which is going to be the sum of the first values in each of the split arrays. Since logically you need to have the first element of the overall array in any split, that's kind of taken for granted, and the main issue is trying to determine how to find the other indices where you're splitting up into the other kind of k-1 portions, where k is the number of subarrays that you're aiming for. Unlike the previous day's problem, this is going to have a certain distance parameter, where the distance parameter is going to limit how far away the first index of the second subarray is from the last index, or the first index of the last subarray. So here, if distance is 3 and you have 3 subarrays, then the second and third subarray must be at most 3 apart on the first indices of them. So anyways, it's going to be 2 and 2 here. Because this last 2 is 3 away from this 2, so this split would be 1, 3, 2, 6, 4, and 2. And the sum of those, the cost of that would be 1 plus 2 plus 2, which is 5. This one, you're splitting them to 4. It has to be at most 3 away from the second and the last subarrays first indices. So here's can be 1, 2, 2, or 2, 2, 1, in addition to the 10. And then this one, 3 subarrays, distance 1 apart from the second, third subarray, so it has to be kind of adjacent. So either is going to be 18 or 18.9 as the other subarrays besides the initial subarray that starts with 10. So 18 is going to be the smallest, so it would be 36. So the way that I thought about this one was ignoring the first subarray, which is always going to have the cost of the first element of the array. I'm basically trying to find the lowest k-1 values, so the lowest 2 values that are 1 apart in the rest of my array. Rest of my array being everything from 1 index on. So here this would be the lowest 3 values that are 3. I can also think of 3 as the length of the subarray that I'm considering. So the lowest 3 in something that is 4, basically, because distance 3 means it can have 4 elements in the thing. Or, sorry, value 3, distance 3 means there's at most 4 things. Because this last 2 is 3 apart from this first one, so there could be kind of, yeah, there's 4 elements that I'm considering, and I'm getting the bottom 3 of it. This one, there's 4 elements I'm considering, I'm getting the bottom 2 of it. So like here it'd be 3, 2 is the bottom 2. Here it'd be 2, 2 is the bottom 2, and that'd be the the best way of getting this one. Alright, so in terms of how to approach this, I first kind of created the trivial case, which is if there is certain parameters where you're basically trying to find the consecutive smallest values. So here k equals 3, distance equals 1 means you're basically trying to find the two smallest that are consecutive. So 818 or 189 or anything that's distance 1 means that it's just a tight group of values, and you're trying to find the smallest grouping of that within the thing. That's just almost similar to find the minimum using a sliding window. So that was this thing right here. So you find the initial kind of tight grouping, and then you use a sliding window approach where the index is the last index in the window, add that to the window, compare that to the lowest total kind of cost of the window. If it's smaller, then update that cost, and then remove the left side of the window so that it's ready for the next iteration of loop that starts by adding to the right side of the window. So here, I guess I'll start with a summary and say that the kind of rethink our problem is equivalently finding the smallest. I'll just call it k, because even though it's actually k minus 1 and you include the first element, that's kind of just an equivalent way of thinking about k. Find k smallest values in a window that is distance long. Technically it's distance plus 1 long. Handle the kind of trivial case separately, which is to find the smallest total of kind of k consecutive elements. Using a sliding window approach. The reason why I do this using kind of a separate case rather than a general algorithm that handles this case in it is the logic is just the logic that I handled the rest of the cases not quite matching this case in when I add certain elements to later on, and I have to assume that certain things are there. This trivial case doesn't have those certain things, so yeah. And then the rest of it is, let's see what I do. So I relabeled k to become k minus 1, just because I wanted to logically think about just the rest of the array and finding the k smallest values of the rest of the array in a distance length, rather than always having to do k minus 1 in my head or in the code. So yeah, I just relabel k to become k minus 1, and if it's the kind of trivial case, which is basically when that value is distance plus 1, then that means it's all packed. So just return the trivial case answer. Alright, so then the second portion is the general case, which is the distance might be such that it allows for elements that are not included within that subarray to be not part of the total, not part of the smallest. So in that case, you're really dealing with heaps. You're trying to keep track of the top or the smallest values of the heap, and maintaining the heap to have the appropriate values. So here I initialize my, so there's going to be 2 heaps. So kind of for the general case, have 2 heaps, and I'll call these, I'll call this heap and others. Heap will track the smallest k values within the window, where the window ends in current index, and then others track other values, kind of track the non-small values in window. Maybe I should have called this heap something like min heap or something. But technically, this is also going to be kind of, this will be a max heap in the sense that this is max sorted and this is min sorted. So heaps generally for Python is going to be min heaps, where the top of the heap has the smallest value. That's by default. I actually did see that they recently added, based on October 7th of last year, of 2025, they added a max version of that heap, so it can be sorted using max. The top of the heap is the max value or the min value. But here anyways, I'm going to use a max sorted heap for tracking the smallest k values, because if you think about, let's say, k being 5, so you're thinking about the smallest 5 values, and let's say distance is 100. So within the last 100 values, what's the smallest 5 values? You really care about the largest of those when you want to kind of remove values, right? Like if the 5 smallest values are 6, 9, 10, and 10, 11, 13, something like that. If there is a new value that's small, let's say 1, then you want to get rid of the 13. You don't want to get rid of the 5 or the 6 or whatever. So you want to get the top of the heap should be kind of the biggest one, so you can kind of, that's going to be at the border of your smallest k and your other non-smallest k's. And then vice versa for the other stuff, if you want to reintroduce one of those values back into the smallest k, then you want to just get the smallest of those, so this is going to be min sorted. Pretty common logic for how to work with heaps is that sort of distinction. So the others, I'm going to keep them as, I'm going to initialize them as having everything from the first kind of distance, and here logically it needs to start with index 1, and to make the indices work it should go to distance plus 2. I'm going to have tuples that are the value and the index, just because I need to keep track of both of those. This is, I did a reverse sort here just because I want to eventually change others to become a heap, and I want to remove the stuff that is the smallest from that. So I'm going to pop from this thing like a, so that's why I have reverse true here. I also need to track the present. So track which indices are present, are actually kind of counted within kind of the min heap, the default heap, using an array of booleans. And I call this present. So that was this thing here. It's is going to be size n, where n is the number of elements in the array. You have your initial total value for all the values that are kind of part of it, part of your smallest k. Heap is initially just empty, and then you're going to initialize your heap to be the smallest k values by taking the back end of others. I wonder if I should just do others.pop here. Yeah, this should probably, no, others.pop is a tuple. I want to just take that reference here. Okay. Yeah, anyway, so this is this kind of getting the smallest k values from the first portion of the nums array. I'm going to say it's going to be present in the heap at that index, total plus equals that value, and then append that to the heap. The low total needs to be tracked, so there's that variable. Heapify needs to be called on both the initialized others list and the heap. Alright, and then here's the main loop, and I think I can probably say for main loop to iterating over every index, kind of starting with starting with distance plus 2, I want to say. So first is kind of remove outdated or no, I'll say outdated, outranged values / indices from heap. Outrange values, remove value from outranged index from heap. So what this means is I think example 1 is a good demonstration here. So if I'm dealing with something where I'm getting top 2 with distance 3, top 2 with distance 3 means that at some point my window is going to be this thing right here, 3, 2, 6, 4, and my heap should basically be counting 3 and 2 as the smallest 2. Now when I iterate and get to this index here, for this 2, at that point, before I kind of insert or consider this thing as added to kind of my window, I'm going to go ahead and remove anything that is at the kind of outside the range of something that would be here, right? The window is going to be between those 4. So this is now kind of at an outranged index, or I said a pass index. And if this pass index is part of my present indices of my heap, then I need to kind of adjust it. I kind of basically want to temporarily kind of remove this 3 and add this 4, because the 4 is part of the window, and the 4 would be kind of part of the bottom 2 of that window. So if that index at the outrange index is present being part of the heap consideration, then I'm going to make it false. I'm going to move that from the total. I'm going to basically try to find something from others to put onto the heap. So first I need to make sure that the top of others is not valid. So if the top of others has an index that is kind of at the pass index or further. I could probably say just before the pass index maybe. Then no, it should be that. It should be less than or equal to pass index. So if the top of others is not good, or the top of others is already part of the heap, then I'm going to just ignore that, pop it, and at that point I can transfer top of others, which should be like before, should be an active value index to the heap. So pop that thing, whatever total it is, whatever value it is, adds to the total. I make it present to the heap, and then I push that onto the heap using heap push max. So remove value from there. So I should say there, if outranged value is part of heap, then remove, or I guess remove it from heap. So make it present false, remove from total. Verify that top of others heap of others is okay, and then remove top of others, which is going to be your low value, your next lowest value, and then transfer to your main heap. Okay, so I guess this is part 1 of this area. So that's all within this. So that's all this if statement here. So that's all this code right here. And then for the rest of the loop here, here there's no more outrange stuff. Part 2 would be add the new value. Add new value at current index to heap, and adjust heap and others. So now it's like the heap is maybe 2, 4 as the low values within range of the current index. Here I'll say the current index is wherever this 2 is. So I'm going to add the 2 onto the heap, and then take away the top of the heap, because then the heap would be 2, 4, 2. Take away the 4 from the top, and then move that to others. So yeah, push the new value using heap push max index. Say that that index is now present, and then again kind of transfer something from the top of the min heap into the others heap. So we need to verify that the top of the present heap is actually present. If it's not present, then it's kind of an outdated tuple in the heap. So pop it, and now remove kind of the worst of the heap. So we pop make that not present, remove that from the total, or adjust the total, so adding the new value, removing the old value. He pushed that old tuple onto others, and if that if the low total is bigger than the current total, or if the current total is now smaller than your kind of tracked low total, then update the low total. And finally just return the first value plus 3 low total. So here this is a add new value index to heap. Yeah, I should really call this like min heap or something. Adjust total present. Again, verify that top of heap is okay. Kind of remove outdated. And then take top of heap, transfer to others. Man, I really should call this something besides heap. This is really poor on my part. And then adjust total present again. And then part 3 would be update low total if current is smaller. And after loop, return low total plus your nums at 0. Yeah. All right. So I got a couple wrongs for sure. Time complexity here was O of n log let's say I did do O of d log d log k. No, I did O of d log d to do initial sort. That was this part right here where I sorted the first distance values for the main heap, for the main loop. It's going to, for the main loop, since it requires inserting into heaps, the size of the heaps will be used as kind of log k when you do an insertion, or log of the size. So I think it's going to be O of the insertions will be O of log k and O of log d. Yeah, because the small heap, or the heap that tracks the smallest k values, is going to be size k roughly, and the other ones would be size others or distance. Others basically based on distance. So I think, and because the loop iterates through every index, it should be, since it iterates over, okay, since it requires inserting, so yeah, since it iterates over every index, overall this should be kind of the max, or overall it should be O of n log k plus O of n log d plus O of d log d. I guess O of d log d is just going to be strictly smaller than O of n log d, so that's fine. Yep, space complexity should be O of d. Yeah, O of d since others heap. Others heap can have kind of distance values. Technically it's like O of d minus k, but they're all the same. Alright,